So in 4.2, we are graphing quadratics in standard form. So the last couple days we've been spending time graphing in vertex form. So now our equations are going to look a little bit different. So we're going to start off with some examples right off the bat. What is our vertex here? So just by looking at the graph, what is our vertex? Awesome. Well, this is -2, so it would be 0. How far do we go down?
Oh, no.
-4. So 0, -4 would be our vertex. Remember, our vertex is always a coordinate point. So we have an x value and a y value. What is our axis of symmetry here?
0.
X is equal to 0. Always need that x is equal to for your axis of symmetry. And then it just comes right from the x coordinate here. Looking at our graph, do we have a max or min? A minimum. Our vertex is at the minimum. And then what's our minimum value? -4. So our minimum always comes from the second number.
Why is it 0?
All right, example 2. We're doing the same thing. What's our vertex? 3, 1. So remember, the x comes first, then the x is which way we move to the left or right. So 3, 1. And what's our axis of symmetry?
3.
X equals 3. Always need that x equals. And then do we have a maximum or minimum here? A minimum. And what's our minimum value? 1. Because our vertex is at the lowest point. All right, so next we have our standard form. So anytime we're dealing with quadratics here, anytime we have a quadratic equation, it's going to have that x squared. In standard form, we always start with our x squared term, then we have our x, and then we have a constant. So it's always going to be x squared plus x plus a constant. Now we're going to have a number in front of the x squared. This number here is always going to be our a, the number in front of the x is our b, and the number at the end is our c. So just the number in front of the x squared is the a. Just the number in front of the x is the b. And then the last number is the c. So if we had an example, 2x squared plus 4x, bless you, plus 6. What is our a? 2. What's our b? 4. And what's our c? 6.
So Ms. Carver, in standard form, we have to find that we basically have to write out what is the A, B, and C.
I'm just giving you an example of how to find the A, B, and C here, just showing you. We're actually going to have to figure out what our A, B, and C is and put it into a formula to find our vertex and axis of symmetry and everything. So you'll see on the next slide how we use our A, B, and C to find everything for our graph. All right, so our parabola. Our graph of our parabola, or our graph of our quadratic equation here in standard form, is a parabola. So anytime we see an x squared, we know our graph is going to be in the parabola shape. If a, so our number out front, if that's positive, it opens upward. If it's negative, it opens down. So if it's positive, we have a smiley face. If it's negative, we have a sad face. Now to find our axis of symmetry, we use this formula here. X is equal to negative b over 2a. So this is the formula that you have to remember. We're going to use in all of our examples after this to find our axis of symmetry. So again, the a comes from the number out front and the b comes from the number in front of the x. So negative b over 2a. And then to find our vertex, we take our axis of symmetry, which is that negative b over 2a. That's going to be our x value in our vertex. And we plug that in to find the y. So remember, our vertex is a coordinate point. The x value comes from our little axis of symmetry formula. And then we need to plug that in into our equation to find our y value. Okay, so I'm going to write our axis of symmetry formula up here because we need it for all of these examples. So if it helps, just write it at the top so we have it in front of us. So negative b, my Apple Pencil stopped working, negative b over 2a. So we want to find the axis of symmetry first because that's the formula we have. So x is equal to negative b over 2a. What is our a? So what's that number in front of the x squared? 1. Perfect. If there's no number in front of it, but that x squared is still there, it's a 1. And then what's our b? 2. The number in front of the x is our b. We don't use the c for these, so you can kind of just ignore that. Now let's plug that into our formula. So we have negative 2 over 2 times 1. What's 2 times 1? 2. So negative 2 over 2. Can we simplify this? Yeah. What's negative 2 over 2? Negative 1. Awesome. So x is equal to negative 1 is our axis of symmetry. We don't use c. It's just not in our formula, so we don't use it. It's not in our formula to find the axis of symmetry, so we don't need it. We're not going to use it. All right, next we want to find the vertex. So do we have the first number in the vertex? Negative 1. So that first number always comes from the axis of symmetry. It's always going to be the same. Now how do we find the y? Plug it in. So we're going to plug in negative 1 into all of our x's. So y is equal to negative 1 squared plus 2 times negative 1 plus 3. What is negative 1 squared? 1. What's 2 times negative 1? Negative 2 plus 3. So it's negative 1 minus 2 plus 3. What's negative 1 minus 2? Negative 1. I mean 1 minus 2. I'm sorry. This is a positive 1. So 1 minus 2 is negative 1 plus 3. Negative 1 plus 3 is 2. So when we plug in negative 1 for x, we get 2 for y. So this is our vertex. So remember, our axis of symmetry always comes from this formula, negative b over 2a. So this is our axis of symmetry formula. And then our vertex is always the axis of symmetry, and then plug in to find the y. So to find our axis of symmetry, we use the formula. To find the vertex, we plug it in. Alright, let's simplify this. So we have a negative 2 on top. What's negative 2 times negative, what's 2 times negative 2? Negative 4. Can we simplify negative 2 over negative 4? What does it simplify to? 1 over 2. Perfect. The negatives cancel, because a negative divided by a negative is positive. Both of them get divided by 2. So we get 1 over 2. So what's our axis of symmetry? 1/2. 1 over 2. X is equal to 1 over 2. Can't forget that x is equal to. Alright, let's find our vertex. What's our first number in our vertex? 1/2. How do we find the second number? Plug it in. So we have negative 2 times 1/2 squared plus 2 times 1/2 minus 5. Alright, we gotta do some math here. Okay, so somebody on Zoom asked, isn't B positive? B is positive. We said B is equal to positive 2, but the formula we plug it into is negative B over 2A. So that's what made this a negative 2 on top. Good question. Alright, so according to Pemdas, what should we do first? Do we have any math going on inside the parentheses? So exponent. The parentheses are just holding our numbers there, so we don't have any math going on. We need to do the exponents. So what is 1/2 squared? Awesome, 1/4. So just think about it as 1/2 times 1/2. Multiply the tops, multiply the bottoms, we get 1/4. So this is negative 2 times 1/4. Next we can do 2 times 1/2. What's 2 times 1/2? 1. Perfect. We have a 2 over 2, which is just 1. And then minus 5. Alright, last thing, let's do this. Negative 2 times 1/4. What is negative 2 times 1/4? So it would be negative 1 over 2, because we get 2 over 4. And then we can divide a 2 on the top and the bottom, but that 2 stays on the bottom. So negative 1/2 plus 1 minus 5. What should we do next?
Add the 1 and the 1/2.
We can, but just to make this a little bit easier, since we're just adding and subtracting everything, Pemdas says we can do it in any order because it's all addition and subtraction. So I'm going to just stick with the whole numbers first and combine these together and then add in that negative 1/2. So just to make our lives a little bit easier so we're not working with fractions every step of the way. So what is 1 minus 5? Negative 4. Alright, now I have to deal with the fraction. So I have negative 1/2 minus 4. How can I subtract fractions? What do I need? Could change it to a decimal, but sometimes they won't always be as pretty as 1/2. So how do...
Why wouldn't it just be negative 4/2?
Well, it would. But how do we add fractions? What do we need? 4 over 1, but what would we have to change that 1 to? Awesome. In order to add fractions, we need the same numerator and denominator. So we multiply the top. We need the same denominators, so we have to multiply the top and the bottom by the same number. So we need common denominators in order to add or subtract fractions. So this becomes negative 1 minus 8 over 2 and over 2. What's negative 1 minus 8? Negative 9. So negative 9 over 2, which is also the same thing as negative 4 and 1/2. So that would be if you were dividing fractions. So we get negative 9/2. I'm going to be honest with you, on the homework, there's probably going to be a decent amount of fractions because I just made numbers up. So you'll get lots of practice working with fractions on the homework. So that's why we have some in the examples now. Yes?
I got lost when you started the vertex with 1/2.
So our vertex, just as a reminder, for the vertex, the first number is always our axis of symmetry, and then the second number we find by plugging it in. So our axis of symmetry was 1/2, so that's why we had the 1/2 there. And then we take that 1/2 and plug it in into all of our x's to find the second number.
Alright. My bad.
No problem. All right, we have one last question on this page. Does this graph open up or open down? Good. It opens down because we have a negative a. So since our a is negative, it opens down. If a was positive, it would open up. So remember, our vertex is like the point at the hump, I guess you could say. Let's say our vertex was up here. Our graph could still open down up here, even if this was like a positive x and y. So like on our graph, we go to the right and we go up, so both of these numbers would be positive, but our graph could still open down up here. So just because the y is negative doesn't mean that we open down. It's only this number here, our a. So whatever our a is tells us if we open up or open down.
Okay.
Okay, first thing we want to find is our axis of symmetry. So what's our axis of symmetry formula? Negative b over 2a. So we want to find what our a is and what our b is. So remember, a comes from the number in front of the x squared. B comes from the number in front of the x. So what's the number in front of our x squared? 2. What's the number in front of our x? Do we have an x? We don't have an x in this equation, so our b is actually 0. So if we had, let's say this was 2x squared plus x plus 5, this is when our x would be, or our b would be 1. If we had an x there but with no number. But now we don't even have an x, so that's when our b is 0. Does that make sense? Okay. All right, so let's plug it in. So we have negative 0 over 2 times 2. What happens when we have 0 on top of a fraction? The whole thing is 0. So what's our axis of symmetry? X equals 0. Perfect. So that 0 on the top means that the whole thing is 0. All right, let's find our vertex. What's the first number in our vertex? 0. It's whatever our axis of symmetry is, which here it's 0. How do we find the second number? Plug it in. So we have 2 times 0 squared plus 5. What is 0 squared? 0. And what's 2 times 0? 0. And what's 0 plus 5? 5. So what's our second number in our vertex? 5. Perfect. Easy peasy. All right, Gilbert, does our graph open up or down? What? What tells us that our graph opens up or down? The A, which is the very first number that we reach here. So if it's positive, it opens up. If it's negative, it opens down. Is 2 positive? Yes. So what does it open?
Sorry.
It opens up. It opens up. Okay. So first thing we want to do is find our axis of symmetry. What's our formula for axis of symmetry? Negative b over 2a. So we want to find what our a is and what our b is. So what is our a?
-1.
Perfect, -1. It's the number in front of the x squared, which is -1. What's our b? -1. Number in front of the x, -1. So let's plug those in. So we have a negative, -1, over 2 times -1. So what happens to that negative times a negative on top? It becomes positive. So we have +1 on top. And then what's 2 times -1? -2. So we get -1/2. So what's our axis of symmetry? X equals -1/2. So what's our first number in our vertex? -1/2. How do we find the second number? Plug it in. So we have -1/2 squared minus -1/2. When you have so many negatives going on, make sure you pay attention to the signs. Be careful, be organized. One little mess up of the sign can mess up the whole answer. So be careful. All right, so Pemdas, what should we do first? Is there any math going on in the parentheses? No, so what's next? Exponents. What is -1/2 times -1/2? +1/4. But we have that negative on the outside, so -1/4. And then we have that minus -1/2 at the end, so what did that happen? Okay, 1/2. +1/2. Now we want to add these. What do we need in order to add fractions? Perfect. Multiply the top and the bottom here by 2. So we get 2 over 4. So now we just add the numerators together. Add the tops. So what's -1 plus 2? 1. And what do we get on the bottom? 4. Bottom just stays the same. So what is our second number in our vertex? 1/4. Good job.
For 1/4, why didn't the negatives cancel out?
For 1/4, good question, because we have -1/2 times -1/2 because it's squared, so we multiply it by itself. So this becomes +1/4, but then we still have that negative outside, so that's where that negative came from. Really good question. So again, just make sure you're careful with your signs. Yeah. All right, Gilbert, does it go up or down? Awesome. This negative a tells us that we open down. On the homework, it'll ask you if it has a max or min. So here, Gilbert, what do you think? Do we have a max at the vertex or a minimum? If it opens down, look at our little opens down. Is this vertex at the max or the min? It's at the max, so we would have a max here. So on the homework, it'll ask you if it has a max or min. You have to know if it opens up or down to determine if it has a max or min. So if it opens down, we have a max. If it opens up, we have a min. Good work today, guys.